Okay, so this mini lecture is going to be on the speed of a longitudinal wave. So we've already looked at the speed of a transverse wave in another video and talking about waves on a string or a spring, some kind of solid medium like waves on a string. And this is going to be very similar to the waves on a string. The equation looks a little bit different. But as we think about a longitudinal wave, that's something like wave moving through a medium in the form of a sound wave, something that, again, shifts the medium in the same direction parallel to the direction of motion. So we got to look at some additional things about that medium and how it exists as that wave moves through it. All right, so when we think back to what controls how a wave can move through that medium, the first thing that probably comes to mind is it's got to be related to the elasticity, right? The flexibility, that sort of elastic property of the material itself. And when we think of the elastic properties of solids and fluids, we think a little bit differently than we do of a tension on a string with the transverse wave moving up and down. We start to think about things like the elastic modulus, the bulk modulus, those properties that we learned in the strain and strain relationships when we looked at forces. So go check those videos out too. So when we think about the speed, the wave speed in a longitudinal wave, it's going to be related to elastic properties of the material. So for a rod, a metal rod that a wave might be traveling through a long rod, so if we look at the case of a long rod, that elastic property is the elastic modulus. And we use a capital E to represent that. If we're looking at wave moving through a fluid, that elastic property is what we call the bulk modulus. We're going to use a capital B for that one. All right, and then of course what that material is going to be important, just like it was important for waves on a string, a transverse wave. We looked at the linear density. We're going to look at the density of the material as another thing that's going to be important for us in waves moving through a material in a longitudinal fashion. All right, so how might this be related to the wave speed in a longitudinal wave in a material? Well, if I increase the elasticity, okay, if I make it more elastic, more easy to be stretched or strained, we might expect that we increase the speed. Might make some sense that, if it's easy to stretch a material, then I can also move those molecules in a compressive and rarefactive way. So increasing the elasticity increases the ability, makes it easier for the wave to move. Okay, so that's going to increase the wave speed in some capacity. Right? Well, what about the density? What happens with the density? If I increase the density of the material, well, kind of like the linear density, that made it a little more difficult, right? So the thinking of density is kind of like a thickness. It kind of makes it difficult for the wave to move through. So that's going to make it more difficult for the wave to move. All right. So how do these two go together? And these ideas give rise to the equations for longitudinal wave speed in materials. And so for a rod, right? We'll use a rod as an example, kind of that solid material. The speed is equal to the square root of the elastic modulus divided by the density. So again, as I increase that elastic modulus, it's easier for the wave to move. I increase the wave speed. If I increase the density, it's more difficult. I decrease that wave speed. All right, so that's our relationship for a rod. And for a fluid, the velocity is going to look very similar, but we're going to use the bulk modulus instead of the elastic modulus. So for a fluid, the bulk modulus divided by the density of that fluid, and of course we take the square root of that. And so here are the two equations that we're going to use when we look at the speed of longitudinal waves. And I encourage you to check out the example problem on calculating the speed of a longitudinal wave. Right? Good job.